The world's largest and most powerful space telescope has revealed unprecedented views of Jupiter. The James Webb Telescope took the pictures of the solar system's biggest planet.
Next, the world's most advanced telescope took another leap forward this afternoon as its mirrors were unfolded 1 million miles from Earth. NASA's James Webb Observatory is the successor to the Hubble Space Telescope.
The James Webb Space Telescope was built to push the boundaries of human knowledge, to look deeper into the cosmos than any instrument before it. Yet with its unparalleled clarity and sensitivity, it has begun returning observations so striking that even NASA has been forced to issue stark warnings. The latest findings from Webb have not merely advanced scientific curiosity, they have triggered a red alert across NASA because of what they could mean for the world. At the heart of this discovery lies a terrifying glimpse into the structure and activity of the universe that challenges assumptions about stability, cosmic safety, and humanity's place within this vast expanse. Before we start, smash the like and subscribe buttons for more updates. The telescope's incredible infrared vision allows it to peer billions of light years away, uncovering light from the earliest galaxies formed after the Big Bang. Recently, Webb turned its gaze toward a region of space that had already shown signs of strange behavior. Earlier instruments had picked up anomalies, shifts in radiation and gravitational effects that hinted at something unusual. With Webb's precision, those vague suspicions were confirmed. Instead of quiet star nurseries or faint clusters, the telescope revealed violent disruptions, colossal structures, and energy outputs that dwarf anything seen before. What startled scientists most was the scale and nature of these events. They were not isolated, but widespread, echoing a level of cosmic volatility that raised immediate concern. The most unsettling revelation centered on a star system on the verge of collapse. Webb detected an unstable giant star nearing the end of its life, far larger than expected for its current stage. Around it, clouds of highly energized particles and gases were being expelled at speeds that could only be explained by catastrophic internal processes. This suggested that the star was preparing to go supernova, a stellar explosion of such force that it can briefly outshine entire galaxies. While supernovae are not new phenomena, the details Webb provided indicated that this one was behaving in an abnormal way. Its composition, speed of collapse, and intensity of emissions implied that its explosion might not follow conventional patterns. NASA's alert emphasized that these deviations could mean unpredictable consequences for its surrounding region of space, perhaps even for nearby planetary systems. More chilling still was the discovery of radiation signatures resembling those produced by gamma-ray bursts, among the most powerful events known in the universe. Webb's instruments detected precursor flashes that scientists suspect may signal a burst in preparation. Gamma-ray bursts release more energy in seconds than the sun will emit in its entire lifetime. If such a burst were directed toward Earth, even from thousands of light years away, the effects could be devastating, stripping away parts of the atmosphere and exposing the surface to harmful cosmic radiation. While the likelihood of direct impact is statistically low, Webb's detection of such potential activity so close in cosmic terms was enough to elevate concerns within NASA. The warning was not issued lightly. It was the result of calculated risk based on data too precise to ignore. Adding to the growing unease was Webb's survey of galaxies at extreme distances. Instead of observing the gentle evolution of cosmic structures, it uncovered young galaxies with supermassive black holes that appeared far more developed than theory predicted. These black holes, millions to billions of times more massive than the Sun, were consuming matter at astonishing rates. The energy released as they devoured gas and stars radiated across the universe, creating luminous beacons visible from Earth. But their presence at such an early stage in cosmic history defied explanation. Standard models suggested it should take billions of years for black holes to grow this large, yet Webb was seeing them almost immediately after the Big Bang. This accelerated growth implied that the universe may be far more turbulent and unstable than once believed. NASA's concern was that if such anomalies existed in the distant past, they might hint at mechanisms still active and potentially influential in today's universe. Webb's clarity also allowed scientists to detect distortions in space-time that could only be explained by the presence of invisible mass on a scale previously underestimated. Dark matter, the mysterious substance that makes up the majority of the universe's mass, had always been elusive, but Webb revealed gravitational lensing effects so intense that they suggested concentrations of dark matter in unexpected places. These invisible structures bent and magnified the light of galaxies behind them, producing eerie arcs and mirrored images. The implication was clear. Dark matter might be distributed in ways that threaten stability, perhaps influencing the movements of stars and even entire galaxies in unpredictable ways. NASA's red alert underscored the fact that this was not merely a curiosity. The discovery hinted at forces shaping the universe in ways humanity had yet to comprehend. Equally alarming was Webb's observation of rogue planets, massive bodies drifting through interstellar space without a parent star. While rogue planets had been hypothesized, Webb's detections indicated they were far more common than believed. Some of these planets, large enough to rival Jupiter, wandered through the galaxy in isolation. Their trajectories suggested past violent ejections from star systems, the result of gravitational chaos or collisions. Though distant, the existence of so many wandering giants raised unsettling questions about stability closer to home. Could our solar system be vulnerable to similar disruptions in the far future? NASA's warning reflected a growing awareness that the cosmic order humanity takes for granted may be far more fragile than imagined. One of Webb's most stunning images came from a nebula cloaked in gas and dust, where newborn stars were emerging. Instead of quiet stellar cradles, Webb saw intense flashes, outflows, and shockwaves. These indicated that the process of starbirth was far more violent than anticipated. The turbulence of creation seemed to ripple outward, reshaping entire regions of space. These discoveries pointed to the possibility that the universe's ongoing cycles of creation and destruction might not be as balanced as once thought. Instead, explosive instability appeared woven into the very fabric of stellar evolution. For NASA, the implications of such volatility suggested that the cosmos was a far more dangerous environment than humanity had dared to admit. Perhaps the most terrifying finding of all came when Webb captured evidence of an enormous void, a vast region of space seemingly stripped of galaxies, stars, and light. While cosmic voids are known, this one was larger and darker than any ever recorded. Its edges showed strange distortions as though matter and energy were being pulled inward. Some scientists speculated that it could be linked to exotic physics, perhaps even tied to the nature of dark energy, the mysterious force driving the universe's accelerated expansion. If this void represented a growing instability, the implications were profound. The universe's expansion might not be as uniform as models predicted. NASA's red alert highlighted this as one of the most pressing mysteries uncovered by Webb, a discovery that could redefine humanity's understanding of cosmic fate. The urgency of NASA's warning stemmed not just from the individual discoveries, but from the combined picture they painted. A universe once thought to be relatively stable now appeared filled with hidden dangers, violent processes, and accelerating anomalies. From stars collapsing in unprecedented ways, to galaxies forming too quickly, to black holes defying timelines, to dark matter exerting unpredictable influence, the cosmos seemed far less orderly than science had believed. Each revelation by itself might have been manageable, a puzzle piece to fit into the grand theory of the universe. But together, they formed an image of instability and potential threat that could not be ignored. For humanity, these discoveries carried a sobering message. The world often views the cosmos as distant, a backdrop for Earth's drama, safe in its remoteness. But Webb's findings reminded everyone that Earth is not isolated from the universe's forces. Radiation, gravitational disruptions, rogue bodies, and cosmic expansions all connect in ways that could eventually influence life on this planet. While not every discovery signaled immediate danger, the recognition that the universe is more volatile than believed forced a re-evaluation of risk. NASA's red alert was as much about awareness as it was about specific threats, a call for humanity to recognize the fragility of its position in the cosmos. The terrifying discovery lay not in a single event, but in the tapestry Webb revealed, a universe alive with violence, mystery, and power beyond comprehension. Each new image, each new spectrum of light stripped away illusions of safety. The James Webb Space Telescope has become not just a tool of exploration, but a messenger, showing humanity truths about the universe that demand attention. As NASA's warning made clear, the cosmos is not simply a realm of distant beauty. It is also a place of immense danger, a reminder that Earth drifts through a vast, unpredictable, and often hostile environment. The red alert triggered by NASA following the James Webb Space Telescope's latest warnings did not arise from a single observation, but from a chain of discoveries that, when placed together, paint a picture far more alarming than any isolated anomaly. To extend beyond what has already been outlined, the additional findings and their broader implications must be explored in depth, not just in terms of scientific meaning, but in terms of how they shift humanity's perception of existence itself. The more scientists sift through Webb's observations, the clearer it becomes that the cosmos is not merely a silent stage for distant wonders, it is dynamic, violent, and perilously unstable in ways never before grasped. One of the most striking dimensions of Webb's findings involved the atmospheres of exoplanets. Previous telescopes hinted that some distant worlds could harbor atmospheres rich with potential biosignatures, but Webb's unparalleled sensitivity revealed something far darker. In multiple cases, the telescope captured signatures of toxic elements such as hydrogen cyanide, carbon monoxide, and heavy metallic compounds floating through skies that might otherwise have seemed stable. The sheer concentration of these poisons suggested violent geological or cosmic processes at play, including frequent bombardment by radiation or extreme volcanic upheavals. Far from being the serene candidates for habitability that scientists once hoped for, many of these planets looked hostile to life at even the microbial level. This forced researchers to confront a terrifying possibility. Habitable worlds may be much rarer than once believed, meaning humanity's chances of finding a second Earth are slimmer than anticipated. For NASA, this realization struck at the heart of long-term survival strategies, driving home the warning that Earth's safety cannot be taken for granted. The telescope's deep scans of stellar nurseries expanded this grim picture. In regions where stars were just forming, Webb captured not only bursts of light and matter, but also evidence of colossal magnetic storms on scales difficult to imagine. These storms twisted and contorted infant stars, producing flares that could sterilize nearby planets before they even had the chance to form atmospheres. Such violent outbursts suggested that even the earliest stages of star systems are fraught with instability, making the creation of truly stable planetary environments far rarer than once assumed. The red alert emphasized this danger. If star formation itself is less predictable and more destructive, then entire solar systems, potential homes for life, may be wiped out before they have the chance to flourish. Perhaps even more unsettling was Webb's detection of signals that seemed to indicate unusual motion patterns in the outer arms of certain galaxies. Instead of stars moving in predictable orbits around galactic centers, some were accelerating at odd speeds, as though being tugged by forces invisible to current models. The gravitational fingerprints suggested the possibility of clumps of exotic matter or hidden objects exerting immense influence. While dark matter remained the leading explanation, some researchers raised the chilling possibility that these irregular motions could point toward phenomena not yet even imagined in physics. NASA's warning reflected the unsettling truth that if such anomalies could affect the stability of entire galaxies, there may be no limit to the surprises lurking even within our own cosmic neighborhood. Webb also pierced deeper into cosmic radiation fields than any instrument before it. The telescope detected vast diffuse structures of high-energy particles stretching across intergalactic space, linking galaxies in mysterious filaments. These radiation highways were far more intense than models had predicted, suggesting that the universe is permeated with invisible energy streams capable of influencing matter across vast distances. For Earth, the existence of such pervasive radiation fields raised difficult questions. Could these filaments shift in ways that direct harmful waves toward our solar system? Could cosmic storms generated elsewhere ripple across unimaginable distances and someday arrive here? Though the immediate risk was not calculable, NASA highlighted the discovery as a terrifying reminder that humanity is not insulated from the broader environment of the cosmos. Another area of concern emerged from Webb's focus on aging galaxies. Instead of observing the quiet dimming and cooling of stars expected in such systems, Webb revealed bursts of renewed activity, collisions, mergers, and sudden ignition of dormant black holes. Entire galactic regions thought to be stable were, in reality, undergoing violent transformations. What this meant, in practical terms, was that the timeline of cosmic stability is far shorter than once assumed. Galaxies do not simply age and fade in peace, they tear themselves apart and reassemble in unpredictable ways. If such volatility could occur in seemingly ancient and quiet corners of the universe, then no structure, not even our Milky Way, could be considered safe in the long run. The telescope also caught evidence of planetary systems being shredded by their own stars. In one dramatic image, a gas giant the size of Jupiter appeared stretched into a distorted shape as it spiraled inward toward its parent star, ripped apart by gravitational forces. The remnants of its atmosphere streamed behind it like a comet's tail. This served as a vivid reminder of the destructive potential locked within stellar systems. Planets, no matter how massive, are not permanent fixtures. They can be obliterated in cosmic instants. NASA's alert drew attention to the fact that such destruction may not be rare at all, but rather a routine fate awaiting many worlds. Adding to the mounting sense of dread was Webb's observation of what appeared to be intergalactic collisions of such scale that entire clusters of galaxies were merging into one another. The violence of these events released unimaginable amounts of energy, sending shockwaves through space that distorted nearby regions of the cosmic web. For astronomers, this suggested that the large-scale structure of the universe is still evolving in ways that could have cascading effects. If galaxy clusters can crash together with such force, then the long-term fate of cosmic neighborhoods, including our own, remains deeply uncertain. In one of its most extraordinary feats, Webb also detected what scientists believe may be primordial black holes, relics from the earliest instance after the Big Bang. Unlike the supermassive black holes seen at galactic centers, these primordial entities were far smaller yet unnervingly dense. Their existence, if confirmed, would mean that black holes could form in ways previously unimagined, scattered throughout the universe like landmines. The presence of such objects would pose hidden risks, as their detection is extraordinarily difficult until they interact with surrounding matter. NASA's warning made clear that the existence of primordial black holes could force a complete rethinking of cosmic safety, as these invisible hazards could wander through space unchecked. Equally disturbing was Webb's contribution to understanding dark energy, the mysterious force accelerating the expansion of the universe. Its detailed measurements of distant galaxies suggested that the rate of acceleration is not uniform but may vary across regions of space. This raised the terrifying possibility that the universe's expansion could behave erratically, with some areas tearing apart faster than others. If such instability were to ripple into our region of the cosmos, the fabric of space itself could stretch in ways that alter the very laws of physics as we know them. NASA's alert reflected the gravity of this finding. The universe may not be governed by steady, predictable expansion, but by fluctuating forces whose ultimate consequences remain unknown. Beyond its distant observations, Webb also provided chilling insights closer to home. Its detailed scans of the outer solar system picked up unusual activity around distant objects in the Kuiper Belt. Several icy bodies showed signs of heating inconsistent with their distance from the sun. Some scientists speculated that unseen influences, perhaps a rogue planet or passing stellar body, could be disturbing the region. While not immediately threatening, the idea that hidden gravitational forces could already be influencing the outskirts of our solar system raised pressing concerns. NASA's red alert underscored the need to consider that Earth's neighborhood might not be as isolated or as stable as previously thought. In addition to these physical threats, Webb's data reshaped the philosophical outlook on the cosmos. By detecting light from galaxies formed just a few 100 million years after the Big Bang, Webb effectively showed humanity a universe that grew far faster and with more violence than anticipated. This shattered the comforting illusion of a slowly unfolding cosmos. Instead, the universe appeared to be in constant upheaval, from its earliest moments to the present day. For a species clinging to one small planet, this realization carried weighty implications. The sense of security derived from the apparent predictability of cosmic laws was eroding, replaced by the unsettling truth that the universe is more chaotic than ordered. The telescope's warning about black holes also reached beyond their mere existence. Webb's infrared sensitivity revealed jets of matter being ejected from supermassive black holes with ferocity strong enough to shape entire galaxies. These jets extended across millions of light years, plowing through intergalactic space and rearranging the environment on colossal scales. The destructive reach of black holes was no longer confined to their immediate vicinity. Their influence extended across cosmic distances, altering the fate of countless stars and worlds. For NASA, the implication was unavoidable. The forces capable of reshaping galaxies were not only real but actively at work, and humanity's galaxy was no exception. Webb also forced a reconsideration of time itself. By looking so far into the past, it revealed that cosmic processes thought to require billions of years actually unfolded in a fraction of that time. Stars, galaxies, and black holes formed with alarming rapidity. This compressed timeline implied that the universe is not only more dynamic, but far less forgiving of stability. Change comes quickly, violently, and without warning. For a civilization dependent on long-term cosmic stability, this was a sobering revelation. Another disturbing element emerged from Webb's observation of pulsars and neutron stars. These ultra-dense remnants of collapsed stars were observed releasing bursts of radiation stronger and more erratic than any previous measurements. Some emitted powerful beams in irregular patterns, suggesting processes deep within their cores that remain mysterious. The potential for these bursts to influence surrounding space made them yet another source of instability. NASA's warning reflected that with every new layer of detail Webb revealed, the universe seemed less like a calm sea and more like a stormy ocean, with rogue waves rising unpredictably. The telescope also uncovered evidence of colossal shock fronts where galactic winds slammed into interstellar material. These fronts were so vast that they spanned thousands of light years, lighting up regions of space with radiation and turbulence. Such violent interactions suggested that even the seemingly empty expanses between stars were anything but calm. Space, far from being a void, was alive with violent energy flows, capable of destabilizing entire star systems. The recognition of this fact carried profound implications for humanity's understanding of safety in the cosmos. In piecing together all of these findings, the broader picture became unavoidable. The universe is not a place of gentle order, but a cauldron of instability. NASA's red alert was less a declaration of immediate doom than a stark reminder of fragility. Webb's discoveries showed that chaos is not the exception but the rule. From the toxic skies of distant planets to the violent births of stars, from the jets of black holes to the accelerating voids of dark energy, the cosmos revealed itself as a place of constant danger. Humanity, perched on a small planet in an ordinary solar system, is not shielded from these forces. Instead, it is subject to them, reliant on fragile balances that could be upended at any time. The implications ripple beyond science. They touch philosophy, existential thought, and humanity's place in the grand scheme. For centuries, Earth has been viewed as a relatively safe harbor in an indifferent but stable universe. Webb has shattered that illusion. The universe is not indifferent. It is actively hostile, filled with forces that could erase worlds in an instant. This realization may mark a turning point in how humanity approaches space exploration, survival, and even its own future. For NASA, issuing the red alert was not only about acknowledging terrifying discoveries, but about urging humanity to understand the stakes. Existence is precarious, and the cosmos is far more dangerous than ever imagined. The James Webb Space Telescope has shifted the ground beneath the foundations of astrophysics, and its revelations have become increasingly unnerving as each new dataset is parsed. The red alert NASA raised was not simply a precautionary gesture. It was a recognition that Webb's clarity has uncovered realities too threatening to ignore. Beyond the supernova precursors, the gamma-ray burst warnings, the unstable galaxies, and the haunting voids, the telescope has continued to provide data that peels back layers of the universe once hidden in obscurity. Each layer reveals a cosmos that is neither serene nor predictable, but instead brimming with volatility, power, and mystery. To carry the understanding further, we must examine discoveries that push into domains of cosmic chemistry, structure formation, time distortion, and deep space dynamics, each one carrying implications that demand to be acknowledged. One of the most startling revelations came from Webb's detailed analysis of interstellar chemistry. By peering through clouds of dust and gas, it identified molecules forming under conditions previously thought too extreme for their existence. Some of these molecules included complex carbon-based chains that bore eerie similarities to the building blocks of life. But instead of suggesting hope, their discovery painted a darker picture. These molecules were not forming in calm, supportive environments. They were appearing in violent radiation-scorched regions dominated by superheated gases and turbulent forces. This raised the unsettling implication that the seeds of life may emerge in hostile conditions only to be destroyed long before they can flourish. Far from being a gentle universe fostering life, Webb suggested it is a universe that constantly generates potential only to rip it apart. A related discovery involved the detection of unstable isotopes in stellar debris. Webb's instruments captured evidence of elements with half-lives so short that their very presence suggested violent and recent nucleosynthetic events. These unstable isotopes were being thrown into space in vast clouds, altering the chemical makeup of entire regions. The implications were sobering. The environments in which stars and planets formed were being seeded with materials that could destabilize early planetary systems. This painted a picture of a cosmos where the ingredients for creation and destruction are inextricably linked, constantly cycling through violent episodes that leave behind unpredictable consequences. Turning to the structure of galaxies, Webb's ability to map vast clusters revealed something scientists had only theorized: bridges of matter connecting galaxies across unimaginable distances. These structures, made primarily of dark matter and tenuous streams of gas, acted like hidden scaffolding holding the universe together. But what alarmed researchers was the instability of some of these filaments. In several cases, Webb observed distortions and apparent collapses within these cosmic bridges. If the scaffolding of the universe itself is prone to disruption, it raises questions about the large-scale stability of everything we know. Galaxy clusters could shift, merge, or scatter under stresses that are still poorly understood. NASA's warning underlined the weight of this discovery. The architecture of the cosmos is not fixed, but dynamic, and its changes are not always gentle. Webb's contribution to understanding cosmic time deepened the unease. Its precise observations of distant galaxies revealed time distortions more severe than expected. Light traveling from these galaxies showed redshifts inconsistent with current expansion models. In some cases, the galaxies appeared older than the universe itself should allow, an apparent contradiction that unsettled astrophysicists. This raised two possibilities. Either the models of cosmic expansion are incomplete, or the very fabric of time behaves in ways humanity cannot yet comprehend. Both options point to a reality where the fundamental assumptions about the universe may be flawed, with implications rippling down to the way we measure age, distance, and motion itself. Closer to home, Webb turned its gaze toward white dwarf stars, dense remnants of once sun-like stars. In one system, it revealed the chilling sight of a planet being torn apart as it spiraled into the white dwarf's gravitational grasp. The debris formed a glowing ring of pulverized rock and gas, a graveyard orbit encircling the collapsed star. While spectacular, this image was also a haunting preview of Earth's own distant future. Our sun, too, will one day become a white dwarf, and Webb's observations made that eventual fate impossible to romanticize. The destruction was not tidy or poetic, but catastrophic, reducing once stable worlds into lifeless debris. NASA's alert used this imagery as a stark reminder. The universe's cycles of creation and destruction leave nothing untouched. Webb's investigation into the cores of active galaxies uncovered yet another disturbing process. In several quasars, galaxies powered by voracious supermassive black holes, the telescope captured evidence of feedback loops so violent they destabilized entire star-forming regions. The black holes were not merely swallowing matter, they were spewing out torrents of energy that suppressed the birth of new stars while igniting catastrophic turbulence in the galactic medium. This revelation suggested that black holes, once thought of as passive endpoints, are in fact active agents of galactic evolution, reshaping their environments with ruthless efficiency. For scientists, this painted a portrait of the universe where stability is fleeting, constantly overturned by forces with no regard for longevity. One of Webb's more subtle but deeply troubling findings came from its study of cosmic dust. Dust, often dismissed as a mere nuisance to telescopes, turned out to be far stranger than expected. Webb revealed that dust grains in some galaxies were unusually large and reflective. capable of scattering light in ways that distorted observations. More than a technical complication, this suggested that dust could play a far larger role in the thermal and optical balance of galaxies than previously understood. If dust can alter the flow of light and energy across regions of space, then the mechanisms shaping galaxies and their evolution may be far more chaotic. NASA highlighted this as a reminder that even the smallest elements of the cosmos can have destabilizing effects when multiplied on universal scales. Even more chilling was Webb's detection of what appeared to be stellar remnants colliding with one another. In one system, two neutron stars, the dense, collapsed cores of massive stars, appeared locked in a spiraling death dance. Their collision, inevitable and imminent, would unleash a kilonova, a cataclysmic explosion capable of forging heavy elements like gold and uranium. But the violent gravitational waves from such an event would ripple across the cosmos, altering space-time itself. While not a direct threat to Earth from such distances, the realization that such collisions are relatively common added to the sense of unease. The universe, it seemed, was filled with ongoing catastrophes of unimaginable magnitude. Webb also contributed to the study of rogue black holes, wandering entities not bound to any galaxy. By capturing faint distortions in light patterns, it provided some of the strongest evidence yet that these black holes drift silently through intergalactic space. Their invisibility makes them almost impossible to detect until they interact with matter. The existence of these cosmic predators emphasized the randomness of danger. At any moment, a wandering black hole could pass near a star system, distorting or even dismantling its delicate balance. NASA's warning stressed this point. The universe is not only dangerous but unpredictable, filled with hidden forces moving silently in the dark. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us. What are your thoughts on NASA's red alert after James Webb's terrifying discovery? We want to hear from you. Thank you for watching and see you next time.